Hello everyone. In today's video, we will explain how boundary detection using morphological gradient method works. In this video, we will explain what the problem is, the mathematical concept behind the morphological gradient, and how we implemented it in Python using OpenCV. And at the end, we will show the visual result. So without any further delay, let's get started. The problem which we are solving over here is to extract the boundary of an object in an image and highlight it clearly. As we have seen, the traditional edge detectors like Canny or Sobel work well, but they depend heavily on gradients and noise levels. On the other hand, morphological gradient method uses simple morphological operations to get robust and clear boundaries, especially for binary or threshold images.
Now we can see in the screen the formula for the morphological gradient.
In this section, I am going to explain the mathematical steps involved in finding the morphological gradient of an image. The morphological gradient is a combination of both internal and external boundaries, and it is mathematically defined as G is equal to A plus B minus A minus B, where A is the input image and B is the structuring element. Let's now understand each step one by one.
The morphological gradient method is built on two fundamental image processing operations, dilation and erosion. Dilation, denoted by A plus B, expands the object boundaries by adding pixels to the edges. It uses a structuring element, represented by B, to grow or thicken the bright regions of the image. On the other hand, erosion, denoted by A minus B, shrinks the object boundaries. It removes pixels from the edges, thereby reducing the size of the foreground regions in a systematic way. The morphological gradient is defined as the difference between these two operations. The difference operation isolates the boundary pixel, creating a precise outline of the object. In simple terms, dilation grows the object, erosion shrinks it, and the gradient highlights the region in between, which is exactly the boundary we want to extract.
We start with an input binary image denoted by A. In this image, the object pixels are represented by white region value 1 and the background by black region value 0. Our goal is to extract the boundary of an object using morphological operation. The first operation we perform is dilation, represented by A plus B. Dilation expands the bright region in the image. It moves the structuring element B over the image and adds pixel to the boundaries. Wherever the structuring element touches the object region. As a result, object appears slightly larger and its boundaries grow outwards. In the figure, you can see that after dilation, the object has expanded. This represents the external boundary of an object. The next operation is erosion, represented by A minus B. Erosion does the opposite of dilation. It shrinks the bright region in the image. The structuring element B moves over the image and removes the pixel from the object boundaries wherever it does not completely fit inside the object. As a result, the object becomes slightly smaller and its edges move inwards, and this represents the internal boundary of an object. Once we have both the dilation and erosion version of an image, we subtract the eroded image from the dilation image. This operation is represented as this. The subtraction removes all the common pixels inside the object, leaving only the difference region which lies on the boundary. In the other words, the difference highlights the transition area between expanded and contracted version of an object, which is object's edge. This results image G is called morphological gradient image. It contains pixels only along the object boundaries. All other internal and external pixels are removed. This means morphological gradient provides the precious outline of the object, combining both internal and external boundaries in one result. In figure, the rightmost images clearly show the boundary formed of the subtract. Now let us move to implementation part. We used Python and OpenCV library to perform this experiment. Here are the summary of steps we followed. Read and convert the input image to grayscale. Apply threshold to create binary image. Create the kernel morphological operations. Apply morphological gradient using CV to get structure element. To execute the program, in terminal you have to type python.filename.py. Before that, OpenCV must be installed in your computer. Thank you.
On the left, we have the original image. In the middle, we have the morphological gradient, which highlights the object's boundary in white. On the right, we have the boundary overlaid on the original image, shown in green. As we can see, the method successfully detects and outlines the object's boundary clearly and smoothly. This approach is simple yet powerful for object segmentation, shape analysis, and pattern recognition.
In the end, I would like to conclude that the morphological gradient method is an effective and efficient way to detect object boundaries in digital images. It relies on basic morphological operations like dilation and erosions and produces clean boundary results. This technique is widely used in industrial inspection, medical imaging, and object tracking. Thank you for watching. If you found this helpful, don't forget to like, share, and subscribe for more computer vision and image processing objects.